Okay, engineers, this is an example of imaginary roots. The procedure is the same. The only difference is that you are going to deal with imaginary roots. Okay, let's do very quickly the calculation of the lambdas. Is going to be, using this formula, is going to be 6 minus lambda minus 1, 5, 4 minus lambda. And let's do the multiplications here. Let's do the 6 times 4, 24, minus 6 lambda, minus 4 lambda, plus lambda squared, and then plus 5, and that should be equal to 0. And then let's organize this by lambda squared, and then minus 10 lambda, and then 24 plus 5 is equal to 29, equal to 0. Okay, I don't see how can we make two numbers in which the multiplication is going to be minus 29 and this 10. This 29 is a very odd number. Okay, so let's use the chicharronera. If we use the chicharronera, then it's going to be lambda 1 and 2 is equal to minus b, so that is going to be 10 plus minus the square root of 100 minus 4 times 1 times 29, and then divided by 2a. Okay, so the result of this is going to be so the result of this is going to be 5, and then plus minus the square root of here is going to be if we use the calculator, is going to be 4 minus 4 here, minus 4, no, minus 16, yeah, minus 16 over 2. And because it is going to be minus 16, then you will have the imaginary root. So 1 and 2 is going to be 5 plus minus the square root of 16 is 4, divided by 2 is going to be 2i. And then you have imaginary roots. Okay, so that is the problem. Okay, even though it is imaginary root, let's use the same procedure to find the values of k vector. Remember this formula: A matrix minus lambda identity matrix times k vector equal to 0 vector. I usually jump directly to the equation, so it's going to be, but with these values of the imaginary root. So it's going to be 6 minus 5 plus 2i minus 1, and then 5, 4 minus 5 plus 2i. You can use the positive or the negative, but you should use only one, not both. You can use positive or negative. If you use negative, it's going to be exactly the same. All right. Okay. So now, if we reduce this, it's going to be 6 minus 5 is going to be just 1, and minus times positive minus 2i minus 1, and then 4 minus 5 minus 1, and then minus 2i, and then 0 and 0. Okay, so how are we going to make a step functions here? Okay, so you have to be very careful here, because we have to make these row zeros. How are we going to make that row zeros? Okay, I'm going to check this number, this 1 minus 2i, and I'm going to use the conjugate 1 plus 2i times my first row. In my first row I have 1 minus 2i. So what will be the result of making that multiplication? So it's going to be 1 plus 4, because the I squared is minus 1, and this minus 2 and 2 is going to be minus 4, but because of the I squared is going to be 4, so that is equal to 5. Alright? And down below we have 5. So what we need is minus to make this minus. Alright? Why we need minus 5 to make this 0? That is the reason. So here I have deduced the operation that we are going to use. So this times my first row plus my second row, and we save it in second row. Okay, so what is the result of that? Check that we are making the steps with imaginary numbers. So we have 1 minus 2i, and then minus 1, 0. And here is going to be 0 because the multiplication of this times this is minus 5 plus 5, 0. Now check this out. This times this, negative times negative, is going to be positive. So 1 plus 2i, and then plus 1 minus 2i, 1 and then minus 1, 0, and 2i minus 2i is going to be 0. So this is 0. So what happens here is that you got the row equal to 0. So that means that we are okay. So the result is this, 1 minus 2i k1 plus, no, sorry, minus k2 equal to 0. I'm going to clear k2. K2 is equal to, this to the other side is going to be 1 minus 2i k1. You can clear k1 or you can clear k2. In this case, it's easier to clear k2 because if you clear k1, then you will have the imaginary numbers in the denominator and that is going to be more difficult. Now I'm going to choose k1 equal to one number. K1 is equal to 1. So k2 is equal to 1 minus 2i times 1, and that's it. Okay, so what happens here? My k1 is equal to 1 plus 0i because it doesn't have imaginary part, but the k2 does have an imaginary part, 1 minus 2i. Okay, so my k vector is going to be something like this, 1 plus 0i and 1 minus 2i, and I'm going to split this into real part and imaginary part. So the real part is going to be 1 and 1 plus, and the imaginary part is going to be 0 and minus 2, the imaginary part. Now, here comes the thing. Formulas. I don't have time to demonstrate the formulas, so let's use the formulas as I told you. So b1 vector is going to be the real part of k vector, which is just 1 and 1, meaning this is b1 vector. And b2 vector is going to be the imaginary part of k vector. So that means 0 and minus 2. This is b2 vector. Now, the solution will be, I'm going to use the formulas from the book. The formulas from the book is, my first solution is going to be exponential of lambda